Okay. Hello, everyone. My name is Bao Minh Tran, and this is again the explanations for my document. So, reading is boring, right? So watching is better. So in here, I'm not gonna go in deep into the concept. I just like briefly go through it so that you don't have to read all of these. Anyway, let's start. So basically our example here is the automatic door, right? We're gonna discuss it step by step how to, in our final goal is to understand what is the state design pattern of this. And okay, so first, we have states, event, and action. So at first, keep that in mind, only three concepts. So here, so we want a automatic door, you can see how it works, like in real life, right? So we're gonna skip that anyway. First is a milling machine. Intuitions, no need. Diagram, no need. Okay, so now we go directly to the diagram. So here, basically, the states is this circle. The events are these arrows, and the actions is basically these things. The things that it change the attributes of the whole, like the whole class, our whole door. Like attributes of a door. So yeah, so basically we can see that where the actions are taken, it is taken by the event, right? So that is our definitions of milling machine. Here, as you can see, um, the actions performed when it exit from one state to another. You see, like this one state to another, possibly itself. So, okay, the code is provided. You can have a look at that, but it's not our goal here. Okay, next is the Moore machine. There's many more states, right? Each rectangle boxes are the states. So, so now let's take a look. Where are its actions taken? Is taken inside the state, right? The state will perform the actions. And here we look at the events. There's no actions in the event. So this is also the reason why this Moore machine is, have more states and looks a bit like, you know, complex than the previous one. Because, for example, here to keep open and open, why do I have to split them? Because imagine like this. If we know that in a Moore machine, it restricts that actions must be taken by the state, must be, like must be. So if I put this, like combine these two, then how can I initialize the timer and count that, keep an eye on that at the same time, right? When it changes from one state to another, it is impossible, right? Because if we transit to that state, then actions must be taken and it's gonna create an infinite loop anyway. So yeah, let's look at our definition. Is that correct? Actions are executed only when they transit to another state, possibly the current state. Yep, of course. Here, the tick, possibly to the current state. So next, okay. So now the final the state design is basically the combinations of those two machines. So here we have another, like concept with partial transitions. Okay, back here, we have these are called the transition, right? So basically these let me check. Okay, so these are called the exit transition because the actions are taken when it exit one state. And these are called the entry transitions. Because why? Because it just basically transit to the other states. Like, yeah. So now we have what called the partial transitions. Okay. They can execute post the things. Yeah, it's conceptual. Anyway, we have three states, right? And now we still have the same idea. The actions must be taken inside the state, right? But know that what do we have here? We have an event that also has an action on it. So, but some event they don't, but some they have. But actually, if we take a deeper look, we can see the difference between these two. Okay, so let's take this example. It's better because okay, so you see, this is an event. This is also an event, but So why this one have an action that this one doesn't? And why this one does is just like an arrow go back into the state itself, and this one just goes to, you know, nowhere. Okay, so the reason is like this. The open state here, it means that the door it remain opened, completely open. I mean, like there's no closing and opening actions here, just completely open. So the object detected method is basically that the door detects a person and then it will keep the door open. So what it means, like if we have a bunch of people, right? So the first person, the door detect them and then it opening and then it completely open, And then what else? Um, if the next person, the door detects that person, so what do you think it will do? Will it, okay, keep counting down the timer to close the door, or it will, okay, I see another person, I will keep it open for another, like it will reset the clock. Okay, so the answer is of course reset the clock because you can see like from reality that there's a long row of people going through an automatic door. No way that like in the middle of the row the door will close and then it open again. No way, right? Otherwise the door will be broken by the people anyway. So yeah, that's the reason for this object detector that it go back into the state. That means is again initialize all of the attributes of a door. But what about this is basically it is responsible for the timer. So it still remain in that state, but the the actions it will reduce the timer by 10 milliseconds. It was like, yeah. So it basically like that is not so, like difficult. So the state design patterns is basically is how we implement the the Millimore machine. Yeah. Yeah, so I think it goes to the code is gonna be better. So in my code, I won't run it because like this will work properly when you run it, no problem. But because I don't have any console right live, so yeah, you can try yourself. It's gonna be a good practice. So here we have a Millimore. You see that we have a class here a little more, and we use the interface. Okay, we say the interface, and we are trying to implement yep this the state. So yeah, okay. So here is basically the door will have these, and we'll like we check for the type of that of the state. If it's like this, and it will do it like according to the diagram. Yeah, but in the state design pattern, we will basically apply the polymorphism. It's called uh like static dynamic dispatch, but basically it's just polymorphism to like remove the switch case. Yeah, it looks more like OOP. Yeah, so we still have an interface that the contract that it say that all states must implement these two method, and we can see it here. So yeah, and here in the method of the class store itself, it just like basically invokes the object detected and tick of that current state, and by polymorphism, it will know which class to to call the method. So I think that's all. It's gonna be a good practice to, you know, try to implement this and run it. Yeah, but that's it. So thank you for your listening. And again, I want to say that watching is pretty boring. I think this video is kind of long. So talking is better, right? You can reach out to me anytime, anywhere, I think, or maybe we can arrange an appointment in advance. So thank you for your listening.